So, Professor AKB, so how long will you stay in Japan?
5 days. 5 days.
days. 5
Yes.
days.
Yeah. And this 5 days I will go back to Taiwan.
Taiwan. Okay.
Yeah, this is my 3 days in
3
Japan.
days.
Yeah.
Oh, okay. So you will go back on Sunday.
No. 5 days.
Friday. I see.
Yes.
So for conference?
No.
No, that's travel.
For
Travel.
AKB?
Just
Travel, yeah.
just sightseeing.
Okay. With your family?
Yeah. Yes.
Oh,
With
I
my
see.
son and my mother.
Oh, I see. I see.
Yeah.
Yeah. Very good.
Yeah. Thank you.
Okay, so let's start our meeting first.
Yeah.
And so is there anything need to discuss about the VTCA conference
Yeah.
from your side?
Yeah. So we will make the presentation at first or BTCA at first. Which one do you like?
Sorry, again.
Maybe our voice is not good.
You want to discuss the VTCA conference first, right?
Okay.
Okay.
Oh, Jerry 上来 Professor Jerry 上来。
Yeah,
我要先设定我
Professor Jerry.
Hello, everything okay? I heard, I see the news is terrible in
没有用这个。
Kumamoto.
Kumamoto,
earthquake.
yeah, yesterday.
Yeah.
Yeah.
So everything okay, right? In
Yeah, okay.
Yamaguchi.
And he are currently okay, yeah.
Okay,
Yeah.
okay.
Yeah.
So
So Professor Ellen, so please start what topics our BTCA?
yes, VTCA. So is there anything need to discuss online this time? For example, yeah, here's
Professor,
something
I
I want
cannot
to.
hear your voice. Not clearly.
Really?
I think
How
this is
about?
my side problem.
So can you hear me? Clear?
Yes.
Can you hear me? Yes.
Yeah, yes.
AKB, clear right now? Can you hear me?
Very clear.
Yeah, me too,
Maybe
me too.
our side, my side.
Okay.
Okay,
So
okay,
right now
Professor.
it's okay, right?
Yes.
So what is the accommodation for the keynote speaker?
Keynote speaker with your
Yeah.
recommended person.
We invited the Professor Yanjin, Yanjin Chen,
Yeah.
to serve as a keynote speaker, but
Yeah.
you want to know what's the where is the hotel reservations for her?
Hotel. Yeah. So
Yeah.
as we discussed earlier with the Professor Ellen, so we will give the three night stay for.
Yes.
But you want to make the same hotel with
Yes.
your group and her.
No,
But
yes.
so during my visit to Taiwan, you have already booked another hotel.
Yes.
Other hotel. So if you already booked for her, so we will pay for this charge. It's also okay.
No, not really. She want to stay at the same hotel. The conference reserved for her.
Conference,
Because so because he will arrive back to Taiwan on the next Monday after the conference in the next Monday. So she want to stay at the same hotel.
Same
She
hotel.
do not, yeah, same hotel.
Same hotel with the conference side or your group?
Yes.
Which one?
It was the conference side.
Conference side. So for the
Yes.
conference side, this time we use the hotel as a conference banquet only. And the conference side is in the university campus, a new university campus in the near the station.
Okay, so we reserve 3 nights hotel for free for the keynote speaker, right?
Yeah.
So where is the hotel?
So according to our schedule, so we only get the same hotel of the conference banquet site is 25, 26, 27.
Okay.
We have no 24.
Okay.
So that is
Okay,
why
yes.
we need to reserve to other hotel.
Um,
So the conference hotel is from 25, 26,
Yes.
27, not 24.
okay. Okay.
Yeah.
Oh, yeah. He will reserve another night
Ah,
by herself.
My
It's okay.
my answer is not for 4 days. So we only receive from the hotel reservation because it is the crowded season. So that hotel is used in golf.
Really?
So that is why we cannot
I
get
see.
our requirements. Just only
Okay.
started. We can get from 25, 26, and 27. So that is
Okay.
why it is not inconvenient because only
Okay,
3
okay.
nights. So that is
Okay.
why. So I would like to ask you for your idea. So if you get the same hotel with your group, so it's okay for 3 day nights. We will pay for that hotel charge. It's also okay. Or another one is we can book another hotel, not the same,
Okay.
the conference banquet hotel. We have other
Okay.
hotels we have already reserved.
Okay. Okay. I will tell her.
Do you
Okay.
like? So please ask her. Yeah.
Okay. Thank you.
Yeah.
Yeah, I see. So, okay. I have no question.
So
Just
Professor AKB, please tell me the hotel that your group already reserved. Mine stay? No?
I remember the hotel is Power. When we a moment we check
I
hotel
check.
name.
We live in the
It's
yeah,
near
I
to
see.
Miyazaki Station.
Yeah,
Let me
the
check.
ART
Art
Miyazaki.
hotel. Okay.
Yeah,
Art
yeah,
hotel.
yeah, yeah. ART
Okay.
hotel. Yes,
Yeah,
Art
yeah,
hotel.
hotel.
Okay.
ART.
Okay. I see.
We check in from Monday and check out at Saturday morning. We live
Monday.
in ART from
Yeah.
Monday to Saturday. Yeah.
Monday. Yeah. So guess your 24, 23 to 28.
Yes, 23 to 28.
I see. Okay. 5 days. Yeah. So she will be the same schedule with you, your group. No.
Yeah. He's a Professor Chen Yanjin, right? Yeah, she will have the same schedules with us in Miyazaki.
Yeah.
For example, the visiting schedule you plan in the Tuesday, right? Yeah, she
Yeah.
will join together. And about we will back to Taiwan on Saturday morning. He will leave. He will still stay in the Miyazaki until the next Monday
Next
morning.
Monday. Okay.
Yeah.
Yeah.
He will take the Tiger airplane to the Taoyuan International Airport
I see.
on Monday morning.
So she will be in our city for 1 week.
1 week. Yes, from
Okay.
Monday to next Monday.
Okay, I see. So I would like to know because of your maybe flight schedule for us to us. Yeah.
Actually, I'm not make sure, but maybe I will the same as Professor AKB. I will fly to Fukuoka first, and then on Sunday or Saturday,
Okay.
and from Fukuoka to Miyazaki on Monday morning, on Monday in the afternoon, together with the Professor AKB, maybe together with the Professor Jerry.
I see. Professor AKB is the Saturday afternoon. He will move
Yes.
to Fukuoka. Yeah, I see.
Yes.
Yeah. So another one is I would like to confirm your group students participants amount because we need to adjust our dormitory,
Yes.
and because we will try to get more the reasonable dormitory if you need.
Yeah, I think I asked them to they can take the Tiger airplane on Monday from
Yeah.
Korean International Airport to fly direct to Miyazaki
Yeah, it's good.
and back to Taiwan in the next Monday.
Okay.
For 1 week.
Yeah.
This is I tell them, but maybe some students, for example, Boyuan, Weiyuan, they will stay more than 1 week. I
One
will
month, one month,
with
one month, one month.
1 month.
month.
I will discuss with them.
Yeah. So Boyan, 3 students, they will stay until March after they graduate to end my laboratory. So your professor
Amazing.
allow you both do all of 3.
Yeah, they can stay in Miyazaki all semester.
Okay, very good. Yeah, yeah. You have to report regularly to your professor by online. It's okay.
Yes. So yeah, the final schedule for my student, maybe we can discuss in the next meeting. Yeah.
Okay, I see. So we need to reserve from Monday to the next Monday for the students. Maybe it may be more possibility of all of the students because they will use the direct flight from Taipei to Miyazaki.
Yes.
Okay, I
Yes.
see.
Yes. So how about Professor Jerry? We have not discussed our schedules. Maybe
Yes. Maybe this time I will follow you, and my student will follow your student schedules, and I will allocate to students from my lab to join the conference. Yeah. So, but I have to choose which one will follow your schedule. Yeah. I will. How many students you will get him to join the VTCA conference? You have the 3 students will join the conference.
no, maybe 10 to 12.
10 to 12
Yeah.
students.
Yes.
You will bring 10 to 12 students.
Yes. So I
Okay.
spent a lot of money.
Wow, 20 students. 20
Wow.
students. Not a,
Can you help me to pay
yeah.
flight ticket also?
Oh
Oh my God.
I asked
I
Professor
need money.
Listening to book the whole hostel for us.
Yeah.
They can live in together. They can live together in the Miyazaki
Yeah.
in the same hostel, right?
Yeah.
Yeah.
Same hostel. Yeah.
Yeah, hostel. Yeah,
Yeah,
they
yeah,
can live
yeah.
together.
Hostel. Yeah. Okay.
Yeah.
Yes.
Yeah. Okay.
So
I
how
think
about
I
AKB?
can. Yeah.
So
AKB? How many
AKB,
students
Professor AKB,
you'll come together with you in this time? AKB?
Professor AKB, Shibuya, he is busy now.
Yeah, like he's busy
I
for
think he's
travel.
moving because he's taking Densha. Taking
Densha,
the train. Yeah, then right now. So I
see.
don't know if the signal is stable.
Yeah.
Or he's looking for some booking informations.
So Professor Ellen, so please bring all of the students for the seminar trip to Miyazaki. You bring all of the students, your lab students.
Yes.
Yeah.
All of my master students
Yeah.
from 0 degree to 2nd degree.
Okay. Yeah.
Oh
So
my God.
how many female students? So approximately.
Yeah, 2.
Okay,
two
because
female.
I arranged the summer kimono wearing during our PDCA.
One is Boyin's girlfriend.
Huh? When?
One female student is Boyin's girlfriend.
Oh, very good. Boring. Yeah.
But they cannot live together because they have to. She need to live with another female student together.
Oh. I
Yeah,
see.
it's
Yeah.
yeah, two female students, so they can live together, live
Yeah.
within a one room.
Okay, I see. So I'm now asking for wearing Japanese kimono for the summer version, not the winter version. We have the yukata, kimono wearing within our BTCA for 1 hour. We arrange. So I will send you the detail. We have the Japanese culture.
Okay. Oh, yeah, I see.
Yeah. So that is why please bring a lot of female students. They will be enjoying.
Oh, but female students, I only have two.
Oh, I see. Please bring your daughters.
My daughters,
Yeah.
they have to go to school. Okay. So anything need to discuss for VTCA conference?
Professor Jelly, do you have any advice for the BTCA conference?
I'm just in an adventure, so I don't have any comments. So
So after Professor AKB is after the trade, so we will discuss in the later version after our discussions.
Okay. So maybe let's start to let my
Precise,
student to
yeah, discussion at first.
to share some research.
Okay.
Okay. So Boyan or William, please go ahead.
Okay. You know. That will why do that thing. And see my screen. Okay. Today I will talk about our music. Okay, today I will talk about our work on chemical phase implementation detection. We start two problems. The first problem is that our facial key point model was not correct enough. It used 6 points on the face, but the joint point and the nose point were wrong. Because our behavior detection is on this point, the error make the behavior to more noise. The second problem is that the radiation detection itself was not correct. The old method used hand to label and had not reliable single, and we had no ground truth to check it. So our plan is for that the one label some data and only 164 had label. We can use the model to explain the data. And the third one, check the accuracy with the metric called OKS. And for turn the key into the behavior signal, let me know what the each step. So we start with 100 for image and label image, and it is clear, but it's too small, so it's not really correct. Then we use the smart to look at more image automatically for each image. The model predicts the
So
point.
the voice is not not very clear.
Yeah.
So it's my problems or
Oh,
Maybe not our side also we cannot clear. Maybe your internet access is not good.
the internet access is not good.
6个，不知道，我听不到他们讲话。对，因为他们现在没有讲话。哦，是吗？
Can you hear me?
Okay.
Now okay.
Right now it's okay.
Now it's okay. Okay, okay. I need to repeat the slide one.
Okay.
Okay.
Okay, okay. We start with two problems. The first problem is that our facial key point model was not correct enough. It used 6 points on the catal face, but the joint point and the nose point were often wrong. And because our behavior detection is built on this point, the error make the behavior signal noise. The second point is that the rumination detection itself was not correct. The old method used pen to label the image. It has non-reliable single, and we had no ground truth to check it. So we plan has 4 steps. The first is use hand label, and I only label 164 image. And the second, use the model to explain the data. The third one, check the accuracy with the matrix OKS. And the fourth, turn key point into the behavior signal. So the data, we start with only 164 use hand label image. There is the version 1. It's clean, but it's too small, so we cannot correctly detect the point. Then we use the first model to look at more image automatically for each image. The model predict the point, and we compare them to the auto label. If they agreed well, we keep the image. And this gave us version 2 with 422 image. Then we repeat this with the second model and got the version 3 with 925 image. The key idea at the bottom, we let the model pick the good sample by itself. People only check the difficult case, and it saves a lot of labeling time. And how to measure accuracy, we use the OKS. This is a score from 0 to 1. The higher is better. And it basically measures how close the predict point is to the correct point. The correct show the OKS for each 6 points. Okay. And the first one is the version 1. And the second one is version 2. And we can see eyes and nose and mouth and jaw. Every vision get better than the dark green bar. Vision 3 are the tallest. On the right, over the score went from 0.596 to 0.651 to 0.723 is 21% improvement. The noise is still the weakest point, but it improved a lot compared to the version 1. So we can see the video. It is better than before we presentation. And here you can see the red line is the joint point X 多少讲 XOR.
Axis.
XSS.
And
XSS.
XSS movement. And the yellow one is the nose and joint distance movement. So we can see the red line, it will be up and down because the joint is moving x-axis. And this yellow line is the nose and joint distance movement. Okay, this is the this one is the curve of the x-axis and the movement. We can see this is the time and this is the movement. It will be up and down. And this picture is the nose and joint distance. And this picture is the frequency of the joint movement. And we can see on this picture, this movement is only 1 second, like 1, 2, 3, 4, 5 in the 5 seconds. Have the 5 movement in 5 seconds. So we can know one petal movement is only 1 second. So this is the rumination frequency. And this is the nose and joint distance. We can see it's the same one. 1, 2, 3, 4, 5. Have a 5 movement in 5 seconds. So we can know the frequency of the nose and joint distance is same is 1 second 1 move. So it's 1 hertz. And we have tests for 6 video. But some of the video is not really correct because the video we are using our phone to record it. So we will move another way. So some of video is not really correct. But the video one is this video. This video is correctly can know the rumination movement. And rumination movement is like 1 hertz. We found it. And we also did the experiment for the all of cattle. All of cattle. The face model has 6 points and the body model has 20 points. Together is 26 points. Our method is simple for the face image. We keep the 6 face point and for the 20 body point with 0. For the body image, we do the upside. We do not change the box and the training setting are exactly the same and the separate model. Why do we feel the 0 instant of relabeling? Because our face image are close up and our body image are full body. No image has both label at the same time. Relabeling is everything will be very, very need a long time. So first we test this vision. And so we test this vision now. And I found the face text is combined model is actually better. It went by 16% from 0.72 to 0.84. This is the positive transfer. For the body text, it went down a little bit by 7.8%. So the conclusion is not separate, it always better. It is a check of the text we with a little data, the face got help. The text with a lot of data, the body lost a little bit, just lost a little bit. So we check the face improve. We found it's not because the specific point. It is because the shared model saw five times more cow image, so it learned better general features that help the face. So we will use this model to predict the cattle face. It's better than only the face image model. Okay, today, thank you.
Okay, so thank you very much. So, William, so please go back to the face recognition iteration approach. So in this time, the Williams studies can be partitioned into two parts. The first part, he used the iteration approach to improve the key joint recognitions for the cattle's face. So as you can see in, please go back to the slide with the video. Go to the slide. Yeah. So as you can see, the video shows that it's very clear. With the model can clearly recognize the 6 key points for the cattle face for the cattle face, and so he used the key points movement features to recognize the rumination behavior for the cattle. So in the next slide, you can see, so go back to here is the time domain and the frequency domain for the x-axis movement and the mouth opening. The mouth opening means that the two joints distance between the mouth and the nose. So you can see the mouth openings event in the time domain, and the x-axis movement in the time domain, and the lower two pictures shows the frequency domains of those two behaviors. So we can use the frequency domain features to recognize the rumination behaviors for the cattle. So this is the first idea. And the next, please go back to the next slide. And the second part, I asked Wei to integrate the key points recognition results with face and the bodies for the cattle. So he integrates the 6 key points of face and the 20 key points of bodies together. So you can see, next I will ask him to show the videos to verify that our approach can successfully recognize totally 26 key points for the cattle with face and body. Yeah, that's his research achievement this time. So please give some comment or advice for him. Thank you very much.
Okay. Frequency domain မပြောင်းဘူး frequency domain မှာပြောင်းနေစမ်းတာ frequency domain မှာပြောင်းလိုက်နာမှာ So please go to the time domain to frequency domain slide. This one. This is the second line is the frequency domain of the movement of the mouth chewing, yeah, mouth opening. So this is the nose and the mouth region of the frequency domain. So so this is one example of the frequency domain. How about another example? They are also the similar type.
Yeah. Like this one. I have test for these three video, and these three video is all of our record, and is same frequency, is no, that is rumination.
So William has already tested 3 videos,
Yeah.
in which the kettles is ruminate.
Yeah.
So
I
we
have
found
another
that,
2 video.
yeah,
You want to
we found
see
that they are
that
very similar.
video?
It's okay. We can show the videos for
Yeah.
us.
Like this one is video 2. Uh, uh, it's a same kettle, and it's another angle or similar angle, and this can see the same is 1 hertz, and
Having similar frequency
yes,
features
similar
in
frequency.
the frequency domain. So maybe we can use such the frequency domain features for recognize the difference behavior between the rumination and the eating. Yeah, next time we will show the
Yeah.
features.
It is
Yes.
very interesting. Yes, very good idea. So not only the image feature, but also from the frequency domain is
Yeah.
very good idea. So in that time, you can use only two key points to calculate the frequency domain: mouse, nose, and mouth.
This in the in this picture only use the mouse point.
Mouse point
So,
movement. Yeah.
yeah, in this curve we only use the mouse point, and in this curve use the nose and mouse point.
Distance.
Distance between
Yeah,
the nose and mouth.
the nose and mouse distance movement.
Okay. So the left one is only the position of the mouse. Position of the mouse.
Yes.
Okay.
The mouse x-axis movement.
Mouse x-axis movement.
Yeah, x-axis movement.
Mouse x-axis movement.
It start with 0 and move like 0.05 and 0.1, like this one.
So for the case of mouse and nose distance means you use instead of the meaning of y-axis movement. Nose and mouth is moving in the nearly the y-axis. So that is why the right one is maybe similar to the y movement, or opening or closing mouth button.
I think
You said this.
yeah, I think the rumination behavior, if the y-axis movement is very is not it's very similar in between different frames So because rumination, the behavior is the move will moving from the left to right and the right from the right to left and so on. So we just use the x-axis to monitor or to observe the rumination behaviors instead of using y-axis information.
Okay, so Professor, your hypothesis is so the eating and the rumination is a little how to say we can discriminate by using the x-axis movement of the mouse. So that is
Uh,
why you focus to the x-axis.
yeah, yeah. And the mouse, the distance between the key points of mouse and nose, the distance variation. So we use these two features. So that's why in the first we use the time domain to observe the curve of the x-axis movement for the mouse, and we use the distance between the mouse and nose movements, and then in the bottom graph, as you can in the bottom pictures, you can see we changed the time domain into a frequency domain. That's quite clear to see the features.
Yeah.
But now we didn't try what is the features of the eating. So next time we will show the eating behavior or eating the graph or picture or curve.
Yeah.
And to maybe we can see the difference between those behavior.
So according to your finding, so the eating and rumination difference between the eating and rumination is more apparent in the frequency domain than in the compared to time domain.
Yeah, maybe because the time domain is quite complicated.
Yeah, complicated.
Yeah, you translate into a frequency domain is very clear.
Yeah,
The feature is very clear.
it's good idea. Yeah. How about Professor Biden? Biden Sasi comment.
Please show me at the beginning of the slide. You have two problems. One is insufficient of 6 key point or something like that at the beginning of first slide. You raised two problems. You raised two problems. Insufficient accuracy of 6 point. 6 point facial key point more. Another is poor rumination, something like that. So, but in your presentation, you show that what you call behavior of only mouth and eyes. So that means you are using only 6 key points. Is it true?
To recognize the eating and rumination behavior, we only use six key points. Yeah, that is true.
Yeah, but your problem is insufficient. What do you mean by insufficient? That is not sufficient to study the 6 point. Problem one.
So maybe he wants to mention the not good accuracy by using only 6 point in the image domain, right?
Yeah, but I think the accuracy can be improved because right now, please go back to the next slide. Yeah, right now the data iteration is only 3 phases. So the first one, he used 164 images to training the AI models, and then the way you use the AI models to recognize the 422 images to recognize the key points, and the William will choose or pick up the correct result around 100. How many? William, how many? About
258.
About 258. This is the OKS is more. The OKS performance is more than 0.65.
Yes.
And the 258 data set will add to the 164 to training again. Then he will generate the second versions models. and use the second version model to recognize the 925 images and pick up around the 360 39 image for the correctness recognized, and use the these images to plus to 422 and 164 to integrate with the more big data set and training to generate a third version third version AI models. So let's write the third version. So I asked him he can use the AI agents to do this, to iterate again and again, to know what is the saturate, how many iteration phase will be our performance will be the optimized. So that is not really the final accuracy performance of our AI models, just only the third versions for iterations. So is that clear?
Yes, Professor.
Yeah.
Also, please show me your result of left eye, right eye, and so on. Here's the bar graph. I think from the bar graph. Yeah, this one.
This one.
Yeah, this one. In your bar graph, it seems to me that left side is always better than right side. Why is it so? Usually, left eye result is better than left mouth. I'm sorry, right is
Because
better than right eye, and left mouth is better than right mouth. Why? What is your idea?
because of
This one.
our image is our data set is like this picture, so we can see the left eyes is clearly we can see it, and the right eyes most of time is being we cannot see the right eyes in the most a lot of time. And the right mouse will be hiding behind this how to say this one.
Okay,
This
okay,
one.
okay.
Yeah,
Because of, right, because of the appearance. Yes.
The data set limitations.
Yeah.
Yeah, so the right eyes will not same with the left eyes.
So this is why I asked them to stay in Miyazaki for a long time in the after VTCA conference, because they can collect a lot of data.
Yeah, from the front of view, front of view. Yeah. So I think within the BTCA, you should stay in the Sumiyoshi farm guest house.
To
Yeah,
collect a lot of data sets.
every day. So we can collect.
Okay.
Okay, Professor.
We can see in each iteration phase, we can increase the performance of the OKS phase by phase. So that's why I asked William to do more iterations times, and to estimate or to verify how many phase for the iterations our performance can reach to the best can reach the best performance for the OKS recognition. Yeah, maybe 10 times or 5 times. We don't know.
Okay, I would try it.
Yeah, very good.
Thank you.
Okay.
Professor Jerry, do you want to give us some comments or advice?
It's very impressive research result, especially for the using the key points on detecting the cattle, mouse, and jaw, and that this moving signal become a time domain to frequency domain. It's a very good idea. And I don't have any
for the comment, but I'm curious about that. Is this video, K20 video, the cattle always rumination?
It's not always rumination. We go there and we see the cattle is rumination, and we quickly we need to record this one.
Because I'm because I'm curious about the curve of the you have the curve about the time domain. Can you switch to the curve slide?
Curve? This
The
one?
time domain. Yeah, this one is in this presentation. This duration is always rumination. Rumination curve, or is have some eating transition from not eating to rumination, not chewing to chewing, or this curve is only records the ruminations, mouth, nose and jaw key points moving.
You say in these two curve, founding the
这
rumination.
个曲线，它只记录了它在反刍的时候的鼻子跟下巴的状态吗？
对对对。
还是说它有包含没有反刍跟有反刍的状态？
就没有动，你有没有在这个图上？没有，因为这个图就是这个影片的图，所以它都是就是一直这样动，
就是有反刍的状态嘛。
Yeah. This picture shows the rumination behavior.
Okay,
Yeah.
so I'm curious about that when the cattle is not eating or not rumination. What's the checking line of these figures? Maybe we can see some difference and make a comparison of the features of this curve, because this curve is very clear. Let us know rumination curve, okay? And how about not rumination? Maybe it's not shaking so heavy, so we can clear to to define what kind of feature of rumination or non-rumination. Even the eating behavior is different. So I'm impressive, and I expect that you can using this signal very well in the future, because have this added evidence of the time domain curve or even frequency domain curve, you can clear to separate this state transitions. Yeah, it's good. Yeah, very good. Yeah, good idea. Thank you.
Thank you.
Yeah, thank you. Good comment. So next time we will try to maybe show the curve result for the kettles when they are in the normal state, not eating and not rumination, and in eating and they are in rumination state, and to show the curve, the variance for everyone.
Yeah, this research has a very good contribution. Firstly, using the key point to define on the face, the cattle's face, and then you use the key point, the movement, to extract the rumination features and the eating features and not eating features. Yeah, it can become a good, very good and novelty idea. Yeah, very good. Thank you.
Thank you.
Thank you very much. So so how about let next students go into present his research.
Okay. So what has
Go ahead, please.
Okay. In my last report, we built the annotation pipeline, an annotator department with several sub-agents. One expert agent.
Where your screen? You hide the presentation slide is hidden by your screen. Your share screen.
Sorry.
คือโอคลิกเรียกมาเนี่ย
Okay.
Okay. In my last report, we built the annotation pipeline, an annotator department with several sub-agents, one expert agent, and one QA agent. In this report, I will focus on building a clear annotation spec and making the annotator agents and the expert agents do their job well. And I found a data set called the LANU peak MRI and CT atlas from peaks about 5 to 6 months old. It has two kinds of the data, MRI and CT. MRI is good for the brain and soft tissues, while CT is good for bones and joints. And this is our focus. Then I use a software to extract the boundary landmarks from the CT, produce the two views on the right-hand side. The first one is skeleton reconstruction and semi-transparent skin and skeleton view. The purpose is to serve as the anatomical basis for define our 25 key points. And my spec covers four things. The core principle locate by bone, press on skin, a point by point define of all 25 key points, each with a reliable grade. The annotation rules is the key points have lies on peak body and peak left right and binary visibility. And the basic every bones is defined with the veterinary anatomical names and cross-check against the CT atlas. And this slide shows how I build the gold sample, which serves as the validation and testing benchmark and the reference for the evaluation matrix. First, I annotate the 25 key points by myself, following the spec for each point. Then the expert agent checks every point by one. If a point looks doubtful, it gives a suggestion. Only the verified and reasonable annotations are kept as the gold sample. After the spec was ready, I start with two methods. The first I call on-zero is the baseline, a single all-in-one prompt where the VLM annotates all 25 key points in one pass over the whole image. And the other is on-A as root. It's based on on-zero. The annotator runs it in for detail, but keeps the whole image in view. And I read two papers to find another good ways to improve. So the first paper I read is a large vision language model good for annotators for image tagging. It's under review at ICLR 2026. The text is image tagged, multi-label classification, where the model assign or relates label to an image. The movement, the mo- the motivation is can VLM auto annotate to replace manual label. And before the method, the paper observes that 3 points and 3 plants types each have different bases. The first one is open-ended. It's too generic. It produces words outside the label set. And the second is multi-option. Pick from a candidate list. Give high recall covering most true label, but it introduced some noise. And the third is binary. Gives high precision and judge each class independent, but it means weak case and it's expensive since you ask class by class. The key inside is multi-option recall and binary precision are complementary, and that's why the paper designed a two-stage framework. First case a wide net, then verify each item. Their solution is a two-stage framework called LV, LMANT. The stage one is P2C, prompts to candidates. They group labels that don't usually shows up together, like mountain and sofa. Ask a multi-option question per group and ensemble several models. This gets a compact, high recall candidate set. And step two is concept align disambiguations. They use GPT for all this model to fix concept problems, adding a super category including look alike or represents a name with a clear flash. Then do a binary check on each candidate. There's also an option human step where a person quickly check the small candidate set. And this is the paper's result. On map, the LV, LMANT models all comes close to human annotations. And with HAC, it even exceeds human. Compared to the baseline, LV element is about 2 points higher, and with HAC, the gap widens to about 2.6, and it saves a lot of GPU's times, about 90%. And the second paper is what does CLIP know about a red circle from ICCV 2023. It starts from the limits of text prompts. Text is good at describe, but it's hard to location, and T-points text need both. So the paper asks 3 questions in there. And
CLIP is also a VLM, but discrimination one. Its score and pick from option. A generate VLM like cloud on the other hand produce new output. And this is the core method, visual prompt engineering. First, the key points. You give a key point name like YIs. The text produce the semantic. Second, candidate location marking. Draw a circle, red circle at each candidate location on the whole image. Third, CLIP does the matching. It compares how well each circle image match the text and pick the highest scoring candidate. And there are two key points tests. Test one, naming key points. The location is known, and the models match names to correct position. And test two, key points localization. The location is unknown, so the model search over a candidate grid, comparing random crop and mark. They also run a marker test, different shape, the circle, arrow, and cross, and colors to compare to get the best marker. The data sets are about bird key points. And this paper makes PCK be valuations. A prediction is correct if it's within a third distance of the ground truth points. And the first result shows the best shape is circle. And red is the best. So in my实验的英文是什么？实验。So in my salt is use red circle. And second, PCK, the red circle clearly beats grouping on both data sets. From example on CUB, which is broad key points with masking the red circle reach 45 versus only 21 for quark. And so there are two methods I derived from the two papers. The UNB comes from paper 1. The decomposition idea. I spread the annotation into stage. Recall which points are visible, then the framework, then the limbs, then the featureless points, all on the whole image, no crop. And UNC comes from papers 2 marking idea. It has sorry. It has 3 steps. The first one is find the points roughly. And the second is draw red circle on the whole image. And then refine each to precise position. And this slide shows the OMC pipeline. And the step 1 is get a rough position for all points. And the second, draw a circle on the whole image. And here I follow the paper setting. Radius equals 6% of the short side. And step 3, verify and refine. I check each circle and move the point to its precise position, allowing a large move if need. And the step 4 is the expert flag. And this is my experimental data, and I choose cloud code of 4.8 to be my BLM models, and I use 3 metrics or normalize as percent body, so they are comparable across image. The average error, the number of gross errors, which points off by more than 25%, and the biggest single errors. This result is only 3 images. And this is the result of four results. And as you can see, the arm A and arm B is not inconsistent. And I think the arm C, this way is the more close to my ground truth. Even if the expert to correct, but there are some key points is also on the mistake case. And this is another
我爸在开会，不然我拿平板给你。
And the arm zero is also very serious over the peak, and arm A and arm C is better than the other 2. And this is our presentation. Thank you.
Thank you very much.
Yeah. So a little bit quite long. So the summary is that I asked the boy to try to use the AI tool to help him to label or label the key points for the peaks. So you can see in the slide, he tried several models, compare models, and the result of the several model compare with the golden samples, and try to find the good models. And in the future, we will use the models to help us to build up the key points data set of the peak. And after we construct the correct data set, we can use the data set to training the AI model to recognize the peak who is moving or has different behaviors. So we can use such key points information to recognize different behavior of the peak. So that is why we right now first we do our research work to find a good AI tool which can help us to label the correct key points for the peak images. Yes, this is the summary.
Thank you. The AI tools for the key point we are AI tools still the key point you look on down.
So Boyin, so which one is good in these two examples?
Is C because
C
it's
is good in both examples, right?
yes, because it's consistent than the other one, than the
Mhm.
others.
Okay. So
And also the key points is almost in the peak body.
okay. So this means that we maybe we in the future we will use the C as an AI tool to help us to label the key points for the image of the peaks. Yeah.
Excuse me. What is the main idea of using the circle, cross, and something arrow and so on? Is there any idea background using those symbols? You use the circle, arrow,
Just
and cross, and so on. So what is the main
just say
idea?
again. Okay.
You means that the main how to the main idea is how to use the AI tool or how to choose the AI agent to uh to to label the key points for the pick images. Is that your question?
Yeah, agent
Or,
Yeah,
we just use the AI. So as you can see, the way present the two papers, they use the VLM, the models. So we want to train the AI agent to they can understand what's inside in the pictures, and they can automatically to label the object in the image. But we need to check first their label is correct or not, and the retraining the models. So after we make sure that the AI agent can correctly recognize or label the key points for the peak images, we can use these models to help us to create a lot of data set.
Okay. Thank you very much.
So according to this figure, so expert correction means this is the manually correction. Expert correction.
That's the expert correction.
Is this one?
Yeah.
So the thesis question is that what is the expected correction?
Correction, yeah.
Voice correction.
就是你那个图，你那个第四个图，
第四个
你那个第四个图，这个 expect correction 就是什么意思？这跟 gold sample 有什么不一样？
第四
就这个对
Gold
expert
sample,
correction。
gold sample means the ground truth. So what is the expert correction?
Yes.
什么是 expert correction？
Oh, sorry. Expert correction is the and the C, the result of C, the three annotators, the results and the expert to correct the unreasonable points. Like the this elbow, there are three annotators and have the three place, and the expert choose the blue one, and each point use this way and to get the expert correction.
So I don't know. then it means that AMC, as you can see, the AMC you can have for one key point, you can see there are several solutions or several candidates, right?
Mm.
So you can choose the expert correction is that finally we choose the correct key points among these candidates, and generate the final result is the expected correction.
Okay, I understand. Okay, Professor. Yeah. So, and according to this figure from the ARM-C, so Boyan used only the blue color is the expert correction. A lot of candidates, among
And
3 or 4
no,
candidates.
it's the every key points will choose the best.
Yeah.
I see. So
Yeah.
select on each key point. Yeah.
Yeah.
Yes.
I see. Okay. Yeah, I see. So we can apply to the not only the peak, so we can apply to the kettle.
Yes, I think it's okay.
Because and here the only one color pick is, so that is why if possible we want to apply to the black car or brown car. Only one color.
Yeah, that's a good question. Yes. So maybe yeah, we also want to use this approach to the kettles with different colors, also with single colors. But we need to try more experiment to make sure that what problem will occur
Yeah.
in the current version.
Yes.
I think there still has a lot of problems if this method is used to the other elements, maybe. So we also need to for the kettles with different colors. I think maybe we have to generate an AI agents for each type or each kind of kettles. Maybe I think.
Yeah. Thank you, Professor.
So for Professor Jerry, do you have any comments or advice?
Okay, thank you. This research is very interesting because I think the annotations works very is you manual annotation always put a lot of efforts on AI training. Yeah. So, I'm just curious about you using the VLM technology. How you guiding a VLM to help the annotation on different different pics image. Yeah, how you guide? You have any prompt engineering or
I sorry. Do you mean how to get VLM to annotate?
so
Yes.
yes.
Yes. I write the spec and very seriously let the VLM to follow my rules to annotate.
Yeah, so I think the first one we have to we need to verify a very clear annotation specification. So like this. So this annotation rule. So we guide the VOM to follow the rule we define.
Yes.
So how many pictures do you get the VOM understand that is a peak?
More than 10 pictures.
Different posts, right?
Yes.
And so it's a few data, and then you just guiding the VOM how to annotate each key point on the designated position, right?
Right.
Okay.
So there's a lot of echoes from Professor Jerry's side.
I turn off my. I don't know.
广为员
Yes. Sorry, could you speak again?
No, I have no question. No. 我觉得回音是从那边来的，
Okay.
不好意思。我觉得这个做得很好。OK，I have no question. Thank you.
Thank you.
echo 是在你那边的人。Okay. So this is the end from our side.
Okay.
Professor,
Yes. So from our side, one student wearable.
Yes.
Please share.
有点回音，是不是那个委员要把
委员，你那里吗？
那对
麦克风，
ไม่ไปมายัง
委员是不是你？
ไม่กันเพียงส่วนไม่เพียง
Okay. Yeah.
Please share.
找到凶手了。
Show you. Okay. 好，录。对呢。来 show. Okay. Please start.
Good evening, everyone. So my name is Nubun Bongsui, and I am a master second year student. So today I would like to discuss about my research, that is like study of temporal evolution.
Can you hear our voice from one student voice? Hello.
Yes, we can hear.
Okay, thank you.
That is about the temporal evolution analysis of fetal Harry variability features during liver time.
姐姐那边嘟嘟屁屁的，姐姐那边屁。
So this is the outline of my presentation. So let me start the background of my research. So during the delivery time, the doctor monitor the fetal Harry to see how the fetus is responding during delivery time. So during the liver process, common process like umbilical cord compression and the placenta issues and other problems can affect the oxygen supply to the fetus. So when these factors are occur during the liver time, the fetus has the the feeders experience the oxygen ligation during the delivery time. So if the oxygen ligation occur for a long time, it can occur the increase the acid level in the blood, and if it is serious, it can be destroy the brain, and other serious problem can be occur. So when this insufficient oxygen problem occur, the feeders respond by showing the abnormal changes in the feeder heart rate pattern. So that is why the study of the feeder heart rate pattern is very important to know about the feeder oxygen and other problems during delivery time. So in my research, I focus on the feeder heart rate. So that means the feeder heart rate means how many the feeder heartbeat per minute. So in this case, so the another term I use for is the feeder heart rate variability. It means how the feeder heart is increasing or decreasing according to the autonomic system. By studying the variation between the feeder heart rate pattern, we can get more information about the feeder problem. So after the delivery time, the doctor checked the feeder health by looking at the blood sample from the feeders. So after delivery time, the doctor took the blood sample from the umbilical cord, and then they do to check the umbilical cord blood analysis. From this analysis, we got the blood gas parameter that which is related to this according to this information. So in my research, I study about the feeder heart rate pattern to find the relationship between the pH value, PCO2, to know about how the feeder heart rate is responding to each type of blood gas parameter pattern. So the objectives of my research is to understand how the feeder heart rates changes as it closer to the delivery time, and how these feeder heart rates are related with the pH and PO2 based on the pH and PO2. So I will explain how my data are collected. So my feeder heart rate data are collected using the internet feeder heart rate monitoring system. So in this case, the Scout electric is attached to the feeder scale to collect the feeder heart rate data. And these data are collected between 2017 and 2022 at Miyazaki Medical Association Hospital. So in total, I have 585 recordings to do analysis. So after getting the data, I will firstly do the data preprocessing step. So this is the example data set for one patient. So in my case, I have the feeder heart rates and uterine condition for the data to analysis. So in my case, I only focus on the feeder heart rate that is directly measured from the electrocardiogram signal. So I only use the feeder heart rate value, which is from the FECG, and the other data are removed from my analysis. So after extracting the FECG data, I start doing the data preprocessing steps. So the first stage is the artifact removal. So for the artifact stage, so in the real case, the feeder heart rate below 50 ppm and above 200 are assumed of the artifact. This is caused because of the sensor movement, sensor error, and the mother movement. So these are not real value in the clinical setting. So the first thing is I remove the unreliable value from this data set. And then after removing this data set, I fill the data using the linear interpolation method to fill the gap between the segments. So after filling the value, I take the data which has 20-minute segment before the last delivery time. So this slide show how I do the data preprocessing step by step. So the first image show the raw feeder heart rate signal data, and then after that I deduct the artifact value, so which are above 250. So after detecting the artifact value, I remove this value from the signal, and then there are missing value between the gap. So for this missing value, I fill the value using the linear interpolation method, and the last figure show the final preprocessing of the feeder array data. So from the preprocessed feeder array signal, I extracted the feature that can give the informative behavior of the feeder array pattern. So firstly, I take the last 20-minute segment before the delivery time. So I took the last 20 minutes before delivery time, and then I divided the 5-minute interval. From each 5-minute interval, I calculate the feature. So these features are calculated based on the 50-second block. So from each 5-minute segment, I subdivided into the 50-second blocks. So from each block, I calculate each of the feature. So I will explain which feature I extracted in the next slide. So from each slide, the first feature I extracted is standard deviation feature. So the purpose of using this standard deviation is to measure how the feeder arrays are changes between the 50-second block interval, and the standard deviation is calculated using the following equation. And in this case, the high standard deviation indicate there have a lot of changes between the feeder array, and the low value indicate there has less stable feeder array variability. So the second, before extracting the second feature, I firstly calculate the difference between the consequent feeder array feature to find the positive, to find the increased feeder arrays and the decreased feeder array. So in this case, I find the difference between by using the formula. So in this case, I subtract the current feeder array value from the previous feeder array value, and this table shows the example of how I calculate the changes between two data points. So in this table, so after calculating the difference between the feeder array data, the plus value indicate there is increased feeder array between the data point, and the negative value represent the decreased feeder array between the data point. So from the increasing feeder array and the decreasing feeder array feature, I firstly calculate how long the upward feeder array take within the each segment. So for calculating the upward duration, I calculate the mean rise height between the block. So this the continuous upward movement is calculated using the following equation, and I explain how the calculation is done using the example. And then for checking how long the downward movement occur between the feeder array, I calculate the mean for depth using the following equation. So I firstly calculate the difference between the feeder array, and then I check whether there is negative value. So if I continuously found the negative value between the feeder array data, I calculate how depth is take between the each block, and for the each block I take the mean values of the continuous downward movement. So and then to summarize the 5-minute analysis for the feature, I average although I take the average value of all of the feature to present the 5-minute segment. And after calculating this feature, I then calculate the sample entropy. The purpose of calculating this sample entropy is to check whether there are similar patterns between the feeder array data. So this sample entropy is calculated using the following equation. So to understand clearly, I explain how my calculations are done step by step. So firstly, I take the 5-minute data point within 5-minute data point for the feed array data, and then I create the pattern using the 2 continuous data points. So for the 2 data points, I create the 1 pattern for the entire data length. And then I compare these 2 patterns to check there is similar pattern between them. This is done by calculating the difference between the 2 points. And after finding the difference between the 2 points, I use the threshold to check the similarity between the pattern. So if there isn't similarity between the pattern, I did not count this as similarity pattern. So if there are similarity number between this pair, I counted in the total numbers of match pattern. And then I continue to check whether there has similarity between 3 patterns by creating the by combining the 3 pattern and 3 data points and create 1 pattern between the data points. And then the checking the similarity approach is then I use the similar method according to the step 2, and then I recalculate the how many similar to the points are between them, and then I calculate the sample entropy to check the behavior of the feed array pattern. So in this case, so if I have more similar pattern, the sample entropy value will be lower. So if the patterns are very different, I have the sample entropy value is higher. So after calculating the feature, I summarize each of the feature based on the 5-minute time segment. So in this case, I plot each of the 5-minute segment before the delivery time to see the trends of each feature. So in this case, for the standard deviation, so within the 20 minutes, the standard deviation feature increase as it closer to the delivery time. So it means that as the delivery time is closer, the variation between the feed array is larger. That means that there are a lot of changes between the feed array pattern. And then for the sample entropy, so within the 20 minutes, as its approach to the delivery time, the value is decreased from 0.34 to the 0.36. That means although there are a lot of changes between the feed array pattern, but the more closer to the delivery time, we found the more similarity pattern between the feed array as closer to the delivery time. And so for the 2 feature, mean rise, highs, and the mean fall, the 2 features became larger as it's closest to the delivery time. So to compare this feature, between this feature, which is to compare the which temporary features are related with which black gas parameter, I firstly find the group compression between the patients. So firstly, I group the patient feature based on the pH value. So I firstly group based on the pH value, and I created a 3 group for the pH value according to the interpretation. And then second thing is I summarize the patient value by grouping the PO2 according to the following threshold. And then to check whether there are differences between the group, I calculate the Kruskal-Wallis test to check if there are any significance between the feed array features. After calculating the feed array feature among the pH group, so I found that based on the 3 group, there is no difference significant between within the 20-minute feature. And also for the sample entropy, there are also similar pattern as closer to the delivery time. And also for the mean rise height and mean fall depth, it also shows the similar approach as is closer to the delivery time. So from this finding, there is no significant changes between the pH group. So after testing the PO2 group, I found out that for the standard deviation feature, there are significant between the groups. So within the 20 minutes before delivery, there we can find out the significant feature starting from the 10 minutes before deliveries and 5 minutes before delivery time. So for the sample entropy, so I find out that the significant feature, the significant starting from the 5 minutes before the delivery time. So for the mean rise height, I found out that based on the PO2 value, so I found out that the significant difference can be found before 10 minutes and 5 minute delivery time. So for the mean for that, there is significant segment before delivery time from 10 to 5 minutes. So comparing to the pH group, in the pH group, we cannot find out the significant pattern between the features. But for the PO2 group, we can find out the before the 10 minutes and 5 minute delivery time, we can find out the significant value based on the PO2 group. So in conclusion, we find out that the feeder hurry features are changes as it closer to the delivery time. And so like the changes between the feeder hurry is increases as it's closer to the delivery time, but before the 20-minute delivery time, the sample entropy decrease. That means that there are a lot of similarity pattern as it closer to the delivery time. So from my finding, there has only one significant group for the PO2 group. So from this finding, I find out that PO2 has more significant and has more association between the feeder hurry patterns. Thank you for your kind attention.
Hello, Professor.
Yeah, I'm here.
Yeah, please give some comments and advice.
So sorry, I miss a little bit presentations, the contents because I'm just driving a car to pick up my daughters. So how about Jerry, you first?
Yeah. Okay. Because I'm in this domain, I'm not I'm not considered in this domain. Yeah. Can you tell me? I'm not understand this topic very more. Can you tell me some a purpose of this research? Motivations can tell us, because the fetal heart rate, and maybe I think you are looking for some relationship with the like the oxygens and pH value. What's the purpose of this research? Thank you.
Please go to the slide. Purpose.
Oh, yeah.
I would like to study about how the feeder hurry behave as it's closer to the delivery time. Like as it close to the delivery time, is there like changes between the feeder hurry is large or small as it closer to the delivery time?
So you're trying to analysis or make a detection model. When is the delivery time estimating when is the delivery time or not?
No.
No.
No analytic.
No. The prediction of the delivery time. The to Papa's car delivery time or prediction around
No. The purpose is how rate variability change during that delivery.
Oh, okay. I got it.
And
Thank
then
you.
whether that variability, how much it will influence to the pH value and after the delivery time, pH value and PO2.
So currently, the doctor can know the blood gas parameter after delivery. But according to our objective, so we can know during the delivery, we can know the blood gas parameter. So this is one of our objective. So that is why the doctor can prepare. So if something's abnormal, yeah.
Okay, I got it. Thank you. Yeah.
Yes. So, how to do the clinical trial, or how to verify the correctness of the prediction or of the estimations approach?
Okay, so we have already received more than 500 patient data from
Mhm.
5 years data from the hospital. So that is why we can know their FHR pattern and also their pH, PCO2 values. So
Mhm.
yeah, so that is why we have the ground truth. So
Mhm.
according to our this analysis, so our, for example, the analysis pattern, so we currently use the, for example, in pH for 3 or 4 levels. So
Mhm.
3 or 4 levels. So based on these pattern of the FH fetal heart rate values, so we can classify the 3 types of the pH level currently. So this is our current situation. But the final goal is the classification. The currently she explained the last 20 minutes we used all of the data to classification, but our original objective is, so during the delivery time we use only the 5 minutes interval. Within the intervals we can predict the pH level in each interval. So that is why those results is the how to say, so at the delivery stage, at the birth or delivery stage, so our prediction is maybe nearly exactly the same as the after the delivery. We can measure the actual pH. Yeah.
Okay.
So also not only the pH, so there are a lot of blood gas parameter, so PCO2 or PO2 and so on. So that is why how to make the model of those pH prediction or PCO2 prediction. This is our purpose, and we use to make this model. We use for example, the entropy value and some standard deviation value and such kind of things we use. We compare what entropy, the sample entropy is good or not, or appropriate or not. What is the most relation between this value to the pH or PCO2? Such kind of things we are finding. Yeah.
Yeah. So, so maybe I think Professor Jerry can give some comments, because if you collect a lot of data, relation data from the pH2 values or PO2, so have you ever to consider use the AI training models to predict or to estimate by pH or PO2 value by using the relation parameters to get, So Jerry,
Maybe we can build an AI model for these applications. Yeah. Because I guess we can finding some using some feature extractions and finding some yeah, the relations, the correlations. Yeah, we can think about that.
The correlation features between these
Yeah.
parameters and do
Yeah.
some the feature engineering to
Yes.
training the AI models.
Yeah. Okay,
Maybe we can.
that's a good idea.
Yeah.
Mhm.
Maybe another. Yeah. Let's my comment.
Maybe next. Yeah. Today I'm because I'm still have some student is to hand over the research. So wait a minute. So next time I can let my student to present our research, how to use the data to have some feature engineering and then building the AI model. Maybe we can find out the idea and the concept of the AI application in this part.
Yeah.
That's good.
So, Professor, so you all may remember. So one of this research collaborator is the professor, our former president Ikena Uwe. Maybe you met in our last conference in ICGC 2014. So he supported those data from the hospital.
Oh, yeah.
Yes, that is why. And another one is, so according to his idea, so mostly in this research, mostly they use the up and down variation, the variability research, and the FHR. But in our current interest is they only want to use the down pattern, not including the upward pattern. So that is why in our calculation we use the downward values to predict those.
I see.
Yeah.
Yeah.
Because according to the clinical, the doctor ideas, the downward is very important to find out the abnormal pattern. So that is why he would like to focus to the downward pattern.
I see.
Okay, I see. Yeah.
Very good. Yeah, very good.
Also, Professor, now we are using only the conventional, like entropy and some other things. So your AI model, if your AI model can extract some kind of key point means a key factor, and it will be useful, challenging to our research.
Yeah. Thank you. Good idea.
Yeah. That may be very different from what we are doing.
Yes.
Yes.
And combining your AI model to the result.
Yeah, compare the results.
Yeah, thank you very much.
Okay.
Okay, thank you. Thank you very much.
Thank you very much.
Thank you very much.
Yeah.
Thank you.
So how about the next meeting, Professor?
Yeah. Next meeting, let me check my schedule. How about I see.
October?
No.
Oh, not October. August.
August, yes.
August. How about let me check my. Sorry, quite busy. August. How about August 18 or August 28?
August 18 is better. 28, I am not in Miyazaki.
Okay. So August 18. 3 weeks.
Yeah.
August 18.
Yeah, 3 weeks later.
August 18. What time?
After 3 weeks.
Yeah.
3 weeks. I think can we start at 3 p.m. Taiwan time,
Sure,
or
I'm okay.
or how about PT? Professor?
So and 3 and 4 p.m. and only in that day I have some meeting from 3 p.m. our time.
So
Interest examination meeting a little maybe I think 1 hour is how about today like the same time 4:30 or hour 4:30 you are 3:30.
okay.
It's okay. Yeah,
Okay.
we 3:30. You're 4:30.
4:30 yeah.
Okay.
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 Thank you,
Okay.
Thank you very much.
Okay.
Yeah.
So Professor
Okay. See
8:30
you.
still
See you next
online.
time.
Yeah, see you. See you.
See you. See you.
Bye bye.
Bye
Bye bye.
bye.
Bye bye.
Bye bye.